As promised, this is the extra practice video for logarithmic equations. If you watch the instructional video, which you should before you try to work these, and you're still a little unsure, then maybe watching these extra problems worked will help you. Now, I do recommend that you copy the problem down and stop the video and you try to work it first and then see how close you come to mine. Now, there is a possibility that you would use different steps. As long as you can validate your steps using the properties and the rules for algebra, if you get the right answer, then you're good to go. So let's see what we have here. I have a half log base 6 of 25 is equal to log base 6 of 23 minus 4x. And since I see these two matching logs on both sides of my equation, I would like to use the one-to-one property. So I need to condense first. Now this one is condensed, but this side over here on the left, I have this coefficient in front of my log. I can use my power property to rewrite this as log base 6 of 25 to the 1/2 power, and this side is going to stay the same. Alright, now simplifying some more over here. We know that anytime you raise a number to a fractional exponent, you can simplify that as a square root. So 25 to the 1/2 actually means the square root of 25, which is 5. So I can simplify this down. Log base 6 of 5 is equal to log base 6 of 23 minus 4x. Okay. Now I have condensed logarithms on both sides and they have the same base, so I can use my one-to-one property to state that 5 is equal to 23 minus 4x, and I'm ready to solve. I'm going to subtract 23 from each side, so I get negative 18 is equal to negative 4x, and then I'm going to divide both sides by negative 4 and reduce, so this makes positive 9/2. Now, since this is a logarithm, I need to substitute this in to my equation up here and make sure that I don't have an extraneous root. So if I substitute that in right here, let's see, I'm going to have 1/2 log base 6 of 25 is equal to log base 6 of 23 minus 4 times 9/2. Okay, that's the substituting. Now let's simplify this real quick. So we already did the simplifying here, and we know this side simplifies to log base 6 of 5 equals, this is log base 6 of 23 minus 4 times 9/2. Well, 4 times 9/2, 2 goes into 2, 4 2 times, so I've got 18. This is going to be 23 minus 18, which is 5. This is a true statement, so that means my answer is valid. Here's our next problem. Log base 3 of 2x minus 5 equals 2 times log base 3 of 6 minus log base 3 of 4. So, I see that all my logs have the same base, and there's logs on both sides of the equal sign. That's what lets me know that this is a possibility for the one-to-one property. I need to condense everything though. Now this on the left is condensed as much as it can go, so I'm not going to change it right now at all. Okay, over here, this needs to be condensed. Since I have a coefficient in front of my log, I don't want that. I can use my power rule, my power property, to make this the exponent of, this number is called your argument. So 6 to the second power is going to be 36. So I'm going to do log base 3 of 6 squared, which is 36, minus log base 3 of 4. Alright, once again, the left is as condensed as it can get. But over here on the right side, now I have a difference, and I can use my quotient property to combine this. Remember, if your logs match as far as bases go, and you have a subtraction sign, you can make this into a fraction. So this would be 36 over 4 log base 3. Now 36 over 4 is 9. So go ahead and simplify that. Alright, Now we have single logarithms, we have matching bases, so we can set up an equation of 2x minus 5 is equal to 9, and then we can solve real quickly. So I'm going to add 5 to each side, and I get 2x is equal to 14, divide by 2, and I get x is equal to 7. I do need to fill my answer in up here to make sure that I don't have an extraneous solution. Now you can fill it in here at your most simplified form. So I'm going to make that log base 3 of 2 times 7 minus 5 equals log base 3 of 9. So this is log base 3 of 2 times 7 is 14, and 14 minus 5 is 9. And yes, this is a true statement. There's no negative log, so that is a valid solution. Okay, here's our next problem. Log base 3 of 4x plus 8 is equal to 4. Now, this is going to be an exponential problem because I have a log equals to a number. So this is log to number. So if you want to copy this down and stop it and you try to work it and then check back and see how you did, that would be awesome. Since this is an exponential problem, I'm going to take my base, I'm going to swing around, this is my exponent, and then I'm going to leave it equals to my argument. That's what that number there is called. Okay? Now, how do we solve this? Well, what is simplified form of 3 to the 4th power? 3 times 3 times 3 times 3 is 81 equals 4x plus 8. Subtract 8 from each side. Now I have 73 is equal to 4x. Divide both sides by 4, and I get x is equal to 73 over 4, which looks real nice. Now, we need to take it back up here and fill it in to make sure that we didn't find an extraneous root. So I'm going to come up here with log base 3 of 4 times 73 over 4 plus 8 equals 4. Okay. Then log, alright, 4 times 73 over 4 is log base 3 of 73 plus 8. 73 plus 8 is 81, so now I have log base 3 of 81 equals 4. Now, how do you check that? Real simple, using your exponential property. 3 to the 4th power equals 81. Is this true? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. And so this is a true statement. It checks. I have no negative in my logarithm, so this is a valid solution. It is not extraneous. Okay, let's look at the next problem. Log of 2x plus log of x minus 5 equals 2. Now remember, if you don't see a base, that base is understood to be base 10. That's your common log. Alright, I see that I have logs on one side and a number on the other, so the log to number is the type of problem. Remember, there was two types. There's log to log and log to number. Now with log to number, you're going to use your conversion to exponential. First, I need to condense this side. Since they're added, I'm going to use my product property and condense these into log base 10 of 2x times x minus 5 equals 2. Now when I distribute this, I've got log base 10 of 2x squared minus 10x equals 2. Now I'm ready to convert this to exponential. So I'm going to take my base, which is 10. I'm going to come over here and get the exponent, and I'm going to set that equal to the argument, which is what that's called, minus 10x. Now 10 squared is 100. So I have 100 equals 2x squared minus 10x. And this is your equation solving. This is not about logarithms. But I am going to tell you, I see right now that that old story of factoring quadratics is coming into play. So if you've had trouble with that, I'm going to drop a link down in the description. You can review it real quick. Otherwise, I'm going to come back up here And I'm going to subtract 100 from each side so that I have 0 equals 2x squared minus 10x minus 100. And I'm going to come up here so I can solve the equation. I'm also going to invert it so that I have 2x squared minus 10x minus 100 equals 0. You don't have to do that. That's just how I like mine. So, solving quadratics. First, take out a greatest common factor. Now, when I take the 2 out of here, I have x squared minus 5x minus 50 equals 0. And then I'm ready to factor this trinomial. We'll factor into two binomials. And the first term will be x in both of them because this is a minus. I've got plus and minus. I need a pair of numbers that multiply to give me negative 50 and add up to give me negative 5. So that's going to be 10 and 5. Then when I solve, I take x plus 5 equals to 0 and x minus 10 equals 0. Subtract 5 from each side. I get x is equal to negative 5, or add 10 to each side, x is equal to 10. So I have a possibility of two answers here. I'm going to take them both back up here and fill them in and see if I get any extraneous roots. So let me come under here, or rather let me go up here and put my answers down. So it's either one of these, and let me erase this so I'll have room. Alright, so first x equals to negative 5. If I take log base 10 of 2 times negative 5, well, I already see a problem because this is going to be log base 10 of negative 10, and that's a no-go. So this already is an extraneous root. Now let's check the x equals to 10. If I put 10 in here, I get log base 10 of 2 times 10 is 20, plus I have log base 10 of, when I put 10 minus 5, that gives me 5 equals 2. Alright, let's condense. This will go, since this is a sum, I can use my product property, and this will be the log base 10 of 20 times 5. So this is log base 10 of 100 equals 2. Now let's check it by converting to exponentials. 10 to the second power equals 100 is what that conversion looks like. Is 10 to the second power equal to 100? Yes, it is. So that is a valid solution. That is an extraneous solution. Okay, let's look at this last problem. Log base 6 of x plus 9 plus log base 6 of x is equal to 2. I see logs on one side and a number on the other, so this is type 2 of logarithmic equations. You're logged a number. That means I'm going to try exponential conversion. Now before I can convert it, I have to condense these two logs. Since they're added together, I can use my product property, and that becomes log base 6 of, and I'm going to multiply x times x plus 9. This is equal to 2. Now when I distribute in here, I get log base 6 of x squared plus 9x equals 2. Then I'm ready for my exponential conversion. Here's my base, so I have 6 to the exponent squared equals my argument x squared plus 9x. Alright, this is 36 equals x squared plus 9x. Now I see a quadratic equation that has to be solved, so I need a 0 over here. Subtract 36 from each side. So I have 0 equals x squared plus 9x minus 36. Our old friend, the quadratic equation. So let me come up here where I got some more space, and I'm going to invert it just to solve it. Make sure I copy it right. Okay, This doesn't have a greatest common factor, so I'm ready to start factoring into my two binomials. I know I'm going to have x and x. Because this is a minus, I know I'm going to have one plus and one minus. Now I need a pair of numbers that will multiply to give me negative 36, but add up to give me positive 9. Well, 12 and 3 comes to, 12 and 3 comes to mind. So x plus 12, x minus 3. Now I'm going to take each factor and set it equal to 0. And then I'm going to solve. This one is x equals negative 12. This one solves to x equals to 3. Right? Now these are just possible answers until I fill them in and make sure they're not extraneous. So let's take negative 12. Now when I come back up here to my original, if I plug a negative 12 in here, negative 12 plus 9 is negative 3. And we've already said that's the sign of an extraneous solution when you have a negative argument in your logarithm. So this is a no. It's extraneous. All right, let's try 3. If I take 3 and I fill it in up here for both of these x's, I get 9 plus 3 is 12, so I've got log base 6 of 12 equals, plus log base 6 of 3 equals 2. Now let's condense. So I've got log base 6 of 12 times 3, which is 36. Now let's check it. Here's your base, here's your exponent, and here's your argument. Is 6 squared equal to 36? Yes, it is. So this is a valid solution, okay? I can do some more problem samples if you need to, so drop me a link or send me a message that you need more logarithmic equations and I'll be happy to work some more. Okay? See you next time. Bye.